Okay, so let's say that you have a power source that's producing AC current. Here I have an old power adapter that outputs 9.5 volts AC, and I want to convert it to DC. If I connect an oscilloscope to it, we can see that we get this nice sine wave. The first thing we can do is to get rid of this negative part of AC, where the voltage drops below zero. We can do that with just a simple diode. The diode prevents the negative half from flowing through, so we only get these positive peaks. My load in this instance is just a 1 kilo ohm resistor and a blue LED. If you look very closely, you can actually see the LED flashing because it loses current in the bottom half of the period, where the diode prevents the current from flowing. What we just made is called a half-bridge rectifier. To improve the circuit further, we can add more diodes in this configuration. Now the bottom part is basically reflected up and we get this bumpy graph. The LED now shines brighter as it gets twice the amount of current in the same amount of time. But for true DC, we want a nice straight line. So in order to achieve that, we can add a capacitor parallel to the LED, which smooths out the graph. If we zoom in, we can actually still see that there are bumps and the circuit is not producing perfect DC, but for our purposes, this is good enough. We could still get rid of the bumps by simply adding more capacitors in parallel or by using a bigger capacitor. The simulation on the right can be found on felsta.com. I've added a link in the description. They've made a really cool interactive simulator where you can play around and add different components to the circuit and so on. Definitely check them out. That's it for this video. Thank you for watching and see you next time.